All right, guys. I guess we'll begin. I'm just gonna let this music run in the background. Tell me if it's annoying or anything. So today, basically, we're going to be tackling. We'll be tackling the basics of movement as a whole. This is mainly going to involve player input movement and not really movement of your other mobs and stuff like enemies. So we'll keep that in a later date. Once Unity loads up, I'll start off by introducing to you the three major, four major ways of moving in Unity. If Unity loads up. All right. If you're wondering why my orientation is like this, it's because of a feature called basically where you can customize wherever you want your grids on Unity. So I just prefer it in this fashion. This is a scene I just had pre-built, and it will basically show you all the different ways in which a player character can be made to move. So first, since this is your first introduction into scripting, I'll show you how a basic script looks when we begin. So when you create a new C# script, name it whatever, but it is important that you try to keep a capital letter in the start and avoid spaces in the name because it'll mess up when you're trying to apply it onto your objects in Unity. So if you open it up, it'll normally open up in Visual Studios. Also, Unity has two different code bases, either Java or C#, but C# is normally the more used and recommended one. So as you can see, when you open up a new script, these are basically Unity Engine libraries that'll just always be there. And void start, as you can read, says it starts does whatever it needs to do before the first frame of your game starts. On the other hand, void update is a function that's called every time a new frame is created in your game. So now basically void start would have all the things like identifying different parts in your game, and update would have anything that will always be changing. Now for movement specifically, I'll show you the the simplest way of implementing movement in your game, and that would be using translates. So okay, as you can see here, I don't have a void start statement because it's not necessary, especially for movement, since movement is a continuous thing that happens throughout a game. Okay. A public class basically refers to the function. So translate is the name of the script basically. So public class translate is referring to the script basically. Anything that you keep as a public over here, right? A public float speed. It implies that this speed is a float that can be changed in your inspector view. I'll show you what that means really quickly. Oops. Yeah. So if you go into your Unity editor, click on the player character that you have here, and in that character you can see that it has like basically I've dragged onto the script onto the player that applies the script. And here, if you see, look at translate, that speed function that I mentioned, which is a float, is now here, like it's present basically. And that's because you called it a public. A public variable can also be referred to from other pieces of code. We'll look at that later on. Okay, if you have any doubts, just ask the mentors in the chat, by the way. And if I'm going too fast, just mention it in the chat. Okay, so void update. As I previously mentioned, void update allows you to basically checks each frame of the game on what is happening in the game. So here I have something called move character. Move character is basically this function down here. Oops. Yeah, move character is this function down here, and it'll take a vector basically. A vector 2 implies that it's a 2D vector, so only an x and y component exists. If it was a vector normally without the 2, it implies it's a vector 3, which would have three dimensions basically. So the new vector 2 input.getAxis. Okay, so the first bit of code I guess we could talk about is input. Input is basically anything that will be put in from the player. This handles all the like the Unity engine will handle all of the input coming in, and getAxis horizontal and getAxis vertical basically refers to horizontal and vertical inputs. Now you might be wondering how like this part has been defined immediately. Well, if you go into your Unity editor, go to edit and check project settings. Over here in project settings, there's something called the input manager. The input manager like has a few predetermined input variants. So for example, horizontal it has a name called horizontal, and it takes negative button as the left and positive as right, or it has an alternative negative button which is A and positive button which is B, which is like basically the common mappings for most games if you've played a few. And vertical is again up, down, and WS, and a few others you might observe quickly. Fire is probably on the mouse. Yeah, left click, left control. Okay, that's strange. Jump is obviously on space. And yeah, this is a very easy way for us to handle handle input in Unity. Though there is also a new API for input, which is still being tested, and once it's tested, they'll probably implement it properly, and that'll be more. That's a lot better, apparently. Okay, so back into the code. Here, this move character function that's called. I'll now talk about the function that like this bit of function that's in here. So transform.translate. Transform basically talks about transform basically talks about this transform basically, and translate refers to motion obviously, and by how much is defined by direction, which is basically this vector being sent to your function, and into the speed, whichever speed you feel like, and time.delta time is basically if you put in speed and without this time.delta time factor, what would happen is your movement would be reliant on the number of frames that your computer is able to output, which isn't a good thing, because if this function is called, if the update function is called multiple times, like 60 frames on someone's computer, but on someone else's computer it's called 50 frames, 50 times a second basically. In that case, you'd have varying accelerations on different PCs based on their specs, which isn't what you want as a game dev. So you use this time.delta time factor, which basically refers to how long it has been since the update function was called. So if you want to look at this number, there's a very simple way of showing values in Unity, and it's basically similar to your print. Like first in C, it's called printf, right? So basically, you can print stuff. So in this, if you want to view certain values and stuff in the console window over here, if you want to see stuff in your console, it's just debug.log. And say for an example, you want to see how long it takes in between each frame. Let's just put that. Yeah, time.delta time. So now if we save this, go into Unity, let it apply. There we go. Now that it's applied, click play. And since the update function is called constantly, you can see that there's a lot of small decimals coming up depending on my frame rate, which seems to be constant. Nice. Nope, it isn't. It just basically gives a lot of numbers right now. This can be used in a lot of bug testing and like checking for errors in your code, or whether certain functions are being applied and stuff like that. So for now, let's begin by talking about translate, like trying out what happens when you use translate. It's not the most recommended in terms of motion for an input character, and you'll see soon enough why. So what we have in our overall scene right now is a floor with just a 2D collider so that the box will land on it. A wall with a rigid body being that physics material, and I just put the mass really high so that it won't get flung aside if my box hits it too hard. And a player character, which also has a rigid body and a few scripts and the 2D collider. I just have an extra here. There we go. Yeah. So the translate script is put onto it already, as you can see, and there's a rigid body 2D and a collider. Wall has a rigid body 2D and a collider. So now if you observe in the play screen, when I hit the right arrow, it will move normally. It seems everything's normal, right? But if you go into player and say you had a slightly larger speed, 30, right? Boom. It just passes through things. Basically, the translate thing just keeps adding to your current position, and if the distance between two objects is small enough, it can just teleport your object through things, and that's why it's not an ideal function for movement. Basically, it's better if you're just trying to do passive things like swiping or sliding across the screen for some reason, like a cutscene or something. Do not use this for character movement. Now this is the more the way that most people would prefer to use movement, and that's called rigid body. By basically shifting the rigid body, i.e. Basically by shifting your rigid body 2D, basically the physics material, that's how we normally apply any kind of movement in games. So even in that, there's three different functions. Okay, let's go through this code one step at a time now. So I called it RB public float speed. Again, this is just a speed vector variable. Public rigid body 2D. So basically, this allows me to copy a rigid body from any part of the game into the segment called RB. So if you go into the player, you see it says none over here, right? If I pick the rigid body 2D from here, just drag it down, and voila, you can just drop it in there. However, for your code to be more self-reliant and less requiring of the input from the user, it's better if you can just input that through code, and that's what this line of code does. RB, basically this variable, is equal to this referring to the game object that this script is on, and that would be your player script, right? So this dot get component. Get component will get whatever component you need from a game object. So get component rigid body 2D. So that's basically referring to the 2D rigid body that's on your game object. That rigid body 2D. Be very specific in how you're saying it. So if you mention just rigid body, this will give you an error because you're trying to put a rigid body 2D into a rigid body, and yeah, obviously classification. And then on top of that, void update. So the void update statement, you say movement is as I mentioned above in the translate function, it's the same thing. Movement is equal to a new vector 2 and then horizontal and vertical. And now this is a slight difference, like we're varying it from the translate function. Fixed update. The thing is with most physics based calculations, if they're occurring at random intervals of time, you first of all can't use time dot delta time on most of these. As you can see, these are just code snippets I'll show you in action soon. But you can't use time dot delta time for most of these, as it will mess with the physics also. So to for a workaround for that, we use fixed update. Fixed update is normally called at a set interval of time each and every single time, and it just won't be reliant on how fast your frames are. You'll have a fixed amount of time after which it's always called. So that's a more reliable way of implementing any kind of physics-based movement, primarily rigid body movement. So again, here's our move character function, which is being called through the fixed update method. Direction being your movement, which is found out in your void update. So then you go rigid body dot add force. Now add force is unique in which that like it acts like a proper force being enacted onto your body. Most games don't use this unless it's for something to do with jumping or anything where a slightly more realistic physics approach is taken. Normally movement is considered a more stand and stop thing where you just move and you just slow down, move and slow down. There's no input lag or something like that, because the force will slowly as it increments, you see it build up and go higher and higher, which is normally not seen in most games. Most games have a fixed amount of speed and you won't go faster than that. So I'll show you this in action so that you can see what I mean. Go into yeah. So I'm just activating the rigid body script. You can just deactivate and activate different parts of your script through just the inspector. For example, if I deactivate the script renderer, it just vanishes. Never mind. If I deactivate the box collider, it'll just fall through the ground, for example. Yep. And yeah, stuff like that. Yeah. So now let's see how force works. Look at that. As you slowly keep holding the button, it starts to speed up. It's moving slower and then speeds up, speeds up, speeds up. And you can, this is clearly visible when I hold up. Okay, I think my force is a little low. Let me just increase it. And this is the like really useful part about public variables, because you can always switch them around and see which fits better. But always remember, if you switch it around in the middle of a game, this will get reset back to its previous value until and unless you change it in the editor. So let's put it to 30. And as you can see, the box starts to go and then it just vanishes. It should come back down because of gravity, but yeah, there. Yeah. So now you see it's back to 10. It's not 30 anymore. If you want to make this 30 permanently, you should switch it here now after the game, like you've stopped playing the game. All right. That was basically add force. This is commonly not used unless it's for some kind of projectile or something along those lines. Rigid body dot velocity. Now this basically adds a fixed amount of velocity and it won't exceed. It's not gonna keep boosting your character. Your character will reach that velocity and just stay there. It's basically the one that's normally used in most platformers and stuff. As you can wait. Oh, I didn't save the changes. As you can see, the velocity is now almost, yeah, it seems constant. Yeah, it's about constant. And up, down, left, right. Yeah. That's basically rigid body dot velocity. Um, Now, this is the one I prefer to use normally, rigid body dot move position. It works similar to velocity, but again, it's a mix between translate and velocity. So it's very stable in how it works, and it shouldn't give you too many errors. But with a very high speed value, it too can pass through objects, if I'm not mistaken. But it's like really large numbers, and at that point, I don't think you'll be creating a game anymore. So yeah, rigid body dot move position. Here it basically refers to the vector 2 transform dot position refers to a vector 2 of the transform of the object, that is the player object's position. This value basically is what is going to be used over here, and then you add like a varying distance amount to this as depending on your velocity and speed. So I did not say that. Yeah. If we play it now, you'll observe that I can't go through objects still, and even if I put it to 30, I shouldn't be ideally able to go through this object. Yep, 30 is not enough. Probably 100 is enough to go through. Nope. Yeah, so it's very stable, as you can see. It's probably not gonna result in your object passing through things most of the time, but people say at a very high amount it may. But yeah, I believe it's the best and most stable method of implementing motion in your game, and it has a lot of control in how you want to use it. And my box fell off. Yeah, so these are the most basic, like base level movements. Now I want to open up a second Unity hub. To show you a slightly more advanced, possibly, yeah, let's just explain it. I'll show it to you after explain. I hope you guys are all up to date with this. Tell me if you're having any trouble, or let mention it in the chat. Okay. Was the doubt cleared about transform? It's basically this component. It refers to this component on your object. Also, yeah, it's still not open. Okay. This part about where is that? Yeah. So here this dot get component does not necessarily have to be there. Sometimes get component directly works, but it's just a more fail-safe way of doing it. So for example, this should have been this dot transform dot position, but it works because transform dot position almost always will assume that it's referring to the game object that it's connected to. Yeah, okay, my second seems up. Fine. Yeah, so this is another pre-made thing that I had done a while back. Let's just scale out. Yeah. Yeah. So this is, I used a YouTuber called Brackies. He had a basic 2D controller, and using that you can basically implement the basic movement in your game. So I'll start off by explaining the steps of the controller. It's a little in depth, and this might be harder for you to get on your first run through. So it's fine if you don't understand it. Just I'm just explaining it as a way for you to like start to grasp it. It's a little like on the long side. So this I'll put this up on the group soon. It's really useful to just create a very basic movement script, because movement is very important, but it's not the end all of your game. So you might want to just skip over it, in which case you would use something like this. So each and every aspect has been commented, and he explains it very clearly. As you can see, jump force refers to the amount of force added when a player jumps. Also, you might be wondering what serialized means. Serialized, basically, for a private float, when it's serialized, it allows you to see it similar to a public float. However, this private float cannot be called by other functions. Just if you have a doubt with that, ask it in the chat to one of the mentors. So, for example, even though even though that these what do you call it, private float, M jump force, M crowd speed, M move smoothing, all of those are all of them are by default private. You can still see them here, as you can observe, as serialized fields. You can change them in the inspector, and that's because of serialized, that like box had a serialized field. You don't need to understand everything in this. So again, range 0 to 1, basically it creates these sliders for you to easily manipulate, and it basically creates a maximum of 1 and a minimum of 0. And yeah, and the further bits, again serialized. This is something that refers to if you want to allow air control, as in if you want the character to be controllable mid-air, then you activate it. If not, you just keep it as false, in which case when the character is jumping, all for a horizontal movement is like basically not considered. And then layer mask refers, this will be a little more complicated, we'll skip that for now. If you have a specific interest, just ask on the group and I'll explain it to you. Again, transform, this refers to it's referring to a very unique sort of thing. So basically in Unity you can create empty objects, right? And all an empty object will have is a transform. That's it. So what we're using an empty object for in this situation is, it's kind of like a cheat code. So there's two empty objects that are held on to my player character. One called the seal. Oof. I think this will allow you to see it better. Yeah. One called the seal, which is just above his head. Yeah. And one called ground, which is just at his feet. So these can be used to identify if your character's head is touching a certain object, or his feet are on on the ground or not. This bit of code is really useful, and it's basically a workaround to a more complicated way of figuring out if he's on the ground or not. So there's that. Transform dot calling check, ceiling check. Sorry, yeah, ceiling check, and then yeah, that's crouch collider. All of these are privates. You won't be able to see them or edit them. And just ignore these for a bit. Rigid body, yeah, ignore these. This portion is the portion you can observe over here. And it's in case you want to add any certain specified events. And it's just, this controller is really like in depth in certain scenarios. So it's not, all of this isn't necessary, but it creates this basically for your understanding. Yeah. So let's begin with private void awake. So basically when this function first is called, it'll get all of these components that are required. Rigid body component, checks if it's on land, if there's an if land on event, which is the ones defined up here, I think. And on crouch event, it's another Boolean event. Uh, okay, again, you see the obvious private fixed update, which is very useful for physics-based stuff. Yeah. So this is a collider 2D. This refers to everything that the object is colliding with right now, and is mainly useful for figuring out if it's grounded or not, if the object is grounded or not. And that's why you can see M grounded is true. If not, if it's not true, then on land event invokes. That you can ignore that bit of code. Public void move. Yeah. So this is your primary move function in this controller, and it has a few bits. Yeah, so if there's a ceiling preventing the player from standing up, then the player will basically not stand up. So that's useful. And that's only if you're not crouching, which is basically when you release the button for crouch. Only controls the player if the ground or air control is turned on. That's only for air control, basically. So if air control is on, it will consider all your input mid-air. Reduce the speed by crouch multiply. So move dot in. Basically, when you're crouching in most games, you'd have a slower movement speed, and that's what this is referring to. It'll reduce your movement speed by a bit, and yeah. Yeah, okay. So this part it's a neat bit of code in the way that Brackeys made his controller. So if you look into the character, I'll just begin by playing it, and you'll observe something that's rather strange. Yeah. Look at that. He can't go above that, and if I jump, he sits in a very awkward manner on objects, and there was no collider over there. So basically, this is because if you use just a basic box collider, look at how he stands. He stands on with floating midair and stuff. So to prevent this, a lot of 2D games actually use two colliders, one box and one circle collider. So let me just show you how to create create the two colliders, and then this thing. I already have a box collider on him, so all I would need is a circle collider. Yeah, circle collider 2D. And now to edit your colliders, you just have to go into save the box collider first. What you want to do with the box collider is it primarily acts for his head and avoid anything that involves his moving body for this part. So anything that touches the ground, you'd rather want the circle collider to deal with it than his box collider. So let's say about that much is your box collider, and then edit your circle collider using the same method. There. And okay, that's a little too small. It's fine if they overlap, by the way. Oof. I'll just switch it in the controller. Let's set it to 0. Okay, that's a bit high. I'd need it that large, and then for the y-axis, let's just shift it. Oh. Hope that's still a little too little. 6. Yeah, 6 is fine. As you can see, it just about reaches his feet, and it's pretty clear. Yeah, just leave these settings, and now he should be easily able to climb this slope, as you can see. Now you might be wondering why he feels so floaty. and that's just because I have gravity scaled as 1. Normally, most games don't actually have realistic gravity scales. For example, if I can recall correctly, Super Mario Odyssey has a 30 meter per second squared gravity measurement value, which is way more than normal Earth standards. So let's just put it at 3 for now. That basically multiplies it by a factor of 3. So he should feel a lot more responsive and less like he's floating in midair. Okay, a little better at least. Right. Okay. Yeah. Okay. So now you observe the two colliders. Now, what I was talking about previously was this bit of enabling the collider when not crouching and disabling the collider when crouching basically refers to enabling and disabling that collider that represents the head, the square collider, in order for you to pass through smaller spaces. So, for example, my character can't currently, like, he won't be able to pass through this gap over here, so to enable this, all you would have to do is put this box collider onto that movement script. So yeah, put this box collider and drag it into the controller's movement script. Yeah, it's already here. And now when you crouch, just the box collider will be disabled and allow his circle part to just pass underneath. It's a unique way of making, like, basically, again, cheating the system. Even though the player won't observe it, it just works. So in ideal cases, we would have animations to show this, which we will be covering next week. All right. So this is about the crouching section of that, and this refers to the movement of the actual character in terms of velocity. As you can see, he uses rigid body dot velocity, and this is an if function that, okay. Basically, you know how when you're facing left or right, your character will switch the position they're facing. So this basically is a flip function that allows the character's model to flip in terms of its facing direction. It's not very important, but it's an aesthetic choice, which is pretty useful in a way. It just looks nice, and it's just pre-built, so you don't have to worry about anything in there. So now the more important part is basically the stuff you will be coding, which is basically, once you get this 2D controller, you'd have to code something along the lines of this: player movement. This is what allows us to give the values that are required for that controller to work. So let's begin with the first few statements. Public character controller 2D. So if you check the name of this, yeah, it's called the character controller 2D, right? So basically, when you name a field using a pre-existing script, it'll only be allowed to hold that that script in that region. So what we do, so it's called controller, and over in player, if you observe, you have something called so this is the player controller, basically on your player movement script, player controller. So again, the rigid body statement. This was because I was trying to add a bit more, but I didn't have time to complete it. These are stuff for climbing. I was just trying to add climbing, but it took a bit too long, so I don't have it complete yet. Maybe you can complete it on the stream. Private float horizontal. It's basically a private float because you don't have to be changing the horizontal and vertical values. If you want, you can serialize it just to see it. Also, be careful. Unity is very specific about its capital letters and stuff like that. So, I think I spelled it wrong. And don't be afraid to use the suggestions. So this will just allow us to observe how the horizontal motion and the vertical motion varies. Um, okay, private void start rigid body. This will get the rigid body component. This is only required for the climbing part. You don't require it for the overall working of the previous code I showed you, because he already refers to the rigid body in his previous script. So void update, same. This is the same motions. Input get axes. This is for the vertical axis. Now here's a unique thing. If input get button down jump, so get button down is another function from the input system, but it looks specifically for if a specific button is pressed. Only on the downward stroke. It doesn't care about the upward stroke. So on a downstroke, jump will activate, which is basically, as you remember from the input stream, it's refers to the space bar. So if a space is pressed, jump is set to true. Jump is a bool, so jump is set to true. And then if input get key down, a key code down arrow. So now this is a way of specifying which key you want to be pressed. So for example, if you have only one input key and it's not a predetermined input IO stream thing from Unity's project settings. So basically that refers to my crouch function. As you can see in project settings, there's no crouch function here, right? So I'll show you later how you can add one too if you want to add a new function. It's actually better to do it that way instead of this, but this is a way you can do it. So you say get key down, not get button down. There's a difference. Get key down and then give it a key code. And in this case, that's the down arrow key. And or else, and this is basically, it'll set crouch to true. Now, for example, in most games, you hold to crouch, right? So as long as the key is down, it'll be crouching. But the minute you release your key, it's considered a get key up of down arrow. And at that point, crouch is set to false. If input get key down, key code C, this is for the climb feature I was talking about, which is still not implemented. I will just quickly. Yep. Right. Now, void fixed update, again, the same old thing. We use it in the controller move function. This will basically call our controller, this controller part, and the controller dot move refers to just that specific function in your controller, which is right, this function, public void move. It refers to that. Now, if this was not a public function, you could not refer to it in other functions. So it's better to just keep things as public. It's easier in that sense. So controller move, horizontal move into time dot fixed delta time, crouch jump. And then after you do any jump, you want to immediately set it to false. So that's why there's a jump false over here. Let's just go. Yeah. So yeah, I can see that we're low on time. I'll just quickly finish up this function, and I think I'll close it for the stream now. Ignore the climbing part again. And now with all of this together, what you should be able to do is your character can move up hills and stuff using that circle collider basically. To prevent bounce, you might have to reduce a circle collider a bit more. That's why it's a little bouncy, as you can see on the edges. And increase gravity, always increase gravity. And now he can jump, although his jump force is very low. I'll just quickly add a bit more. Yep. All right. So he can jump And now you see, you can't go through. The minute I hold the down button, I'm guessing the circle's a little too large. Um, hmm. Yeah, the circle's a little too large. Right, this should allow him to pass underneath that obstacle. Um, yeah. Yeah, as you can see, he can pass underneath it. And right now, even though I release the up button, it won't get up because the controller has a predetermined like function that prevents you from uncrouching midway through this thing. And now he's again back up. And yeah, he barely can jump because I scale. As you remember, I scaled gravity to 3 times, and now, yeah. Um, Oh yeah, about adding the crouch function. If you wanted to add crouch to your input stream, you just go into project settings, pick any of them. I would say for crouch, just pick jump and right click it, duplicate array element. And now you have 2 jumps. Rename this one of them to crouch and say put that as down arrow key, I guess. No, wait, that would interact with vertical. I'll just put it as C, I guess, crouch. That will interact with something else in my code. Yeah, Z. For now, Z is fine. Ignore most of everything else. Yeah. Now with this, what you can do is go into your player movement script, and you can replace this key code down arrow with button down and crouch and right. With all of this, it should still ideally work. I hope I didn't break it. If you use a undefined term in your code, Unity will give you a warning in the console saying it's not known. I'll just test that now. Yeah, see, there's no warnings here. These are just what do you call it? Alerts in a way. And I still should be able to work. Okay, maybe not. Oh yeah, by the way, if you observe, there's that stickiness between player and these like objects. To prevent that, what you need to do is physics material put onto him. This was supposed to be originally covered, I think, when we were doing colliders and stuff. But yeah, so there's something called physics materials, and just drop the friction to 0, so he just slips off of all objects. And using that, it should allow the player to just slip off of any kind of object. Wait, is that? Huh. I think that might be because my collider is getting stuck. Oh wait, yeah, I did apply the physics material. Oh, I think both. Yeah, both of them need the same physics material. It wouldn't. Yeah, as you can observe now, it almost worked. Yeah. So that's most to cover today. And if you have any doubts, drop it in the comment section or in the group. And what else? Yeah, I think that's it, guys. Thanks for watching. Thanks for tuning in. See ya. I'm gonna end doubts. I'll just check for a few doubts. It's from it's Celeste.